Welcome to the webinar. This webinar, Can Every Building Be Smart? The answer may surprise you. We are part of the European Sustainable Energy Week 2025. Yes, the theme this year is Powering a Fair and Competitive Green Transition, and this event is part of the Sustainable Energy Day. And next up, we have Matteo from RINA as Energy Transition Team Leader, and he will be our moderator today. Matteo, you can take the floor.
Okay, thank you so much, Kanisha, and good morning, everybody. Welcome to this webinar. I'm quite happy to be the moderator of this session, introducing the argument and also introducing the different experts that are present today, representing the T project that Kanisha was mentioning before, to discuss about this topic. I'm a mechanical engineer. I've been working in RINA since 2013. I'm an expert on energy systems, and recently I was covering the topic of digitalization in buildings and the industrial sector. So the next slide, please. So just we would like to introduce the topic. So with the definition of smart buildings, but first I would like to start to try to briefly answer to the question: Can every building be smart? So my first answer is yes. Why not? But there are different level of smartness, and the level of smartness depends on several factors. And we are going to discuss today about these factors with the expert that I mentioned before, and that are representing the three EU projects that are dealing with the topic. Then my second question would be how making a building smarter is affordable from an economic and environmental perspective, and how our comfort level could be also increased by the digitalization of our home and workplaces. So the second question is following the first one. And of course, the economic affordability is not a trivial point, and because we are talking about several millions of buildings across Europe, and so this is the first important aspect. But then comes also the environmental consideration and also the comfort perspective. That is probably the first point that comes to our minds. So what is a smart building? According to the European Commission, the smart buildings use technologies to actively sense, interpret, communicate, and respond to changing conditions in relation to its system, the external environment, and occupant demands. This is the official, how to say, definition of a smart building from European Commission. Next slide. And of course, the European Commission is addressing this topic of digitalization of buildings, basically through this directive, the APBD, that is setting several goals for increasing the efficiency of the buildings. And within the goals, as I said, there is this challenge of digitalization. And in the next slides, we are introducing one of the key aspects of the PB directive, that is the smart readiness indicator. The smart readiness indicators is a tool that the European Commission is working on to become one of the main instruments to define and identify the level of smartness of our building. This is an important tool that is still in the development and testing phase, and the idea is to make this tool sort of mandatory in also in alignment with the other tool that is the energy performance certificates, that it's quite standard tool nowadays for the evaluation of the performance of the buildings. Next slide. So today we are going to go through this topic of the digitalization, leaving the floor to the expert, as I said before, that are representing these three projects: SMARTeeSTORY, BuildOn, and Ren+Homes, and that are three European projects that are currently ongoing, and that they are dealing with this topic of digitalization, SRI, and energy positiveness of buildings. The next slides, I'm going to introduce the speakers that are Anna from Tecnalia and Pablo from TU Delft, that are representing the SMARTeeSTORY project, Dimitrios from University College of London, and Kristian from Icons, representing the BuildOn project, and Meritxell and Margherita from Evowall, and Margherita from RINA Consulting, representing Ren+Homes. And now I leave the floor to them individually to introduce themselves and to try to answer to the first questions, and understanding from them what is their perspective of the smart buildings. Please, Anna and Pablo, the floor is yours.
Hi, good morning. Well, my name is Anna, and it says there I'm an architect, and I have a PhD in energy efficiency and sustainability. And my focus is mainly on indoor environmental quality. And to try to answer this complex question of what is a smart building for me, a smart building seeks a balance, between the efficiency and comfort, so it can adapt to its occupant in a smart way. I think more or less this is a summary for me. I don't know if Pablo more or less agrees.
Yes, I agree with you. Hello, everyone. I'm Pablo from TU Delft. I'm PhD researcher at the Faculty of Architecture and the Built Environment. And together with my colleagues, Alessandro and Pedro de la Barra, in the SMARTeeSTORY project, we try to understand better occupant requirements for informing building controls, or let's say smart buildings. For us, or maybe for me, smart building is a building that can understand the user's demands, as well as the users can understand the building and its behavior. And only by doing this bidirectional understanding, we think that we can push traditional bounds of comfort and also energy efficiency. Thank you. I think you're on mute, Matteo.
Sorry. Can leave the floor to Dimitrios and Kristian from BuildOn.
Okay, welcome everyone to this webinar. My name is Dimitrios Rovas. I'm a professor of building simulation optimization at University College London in the UK. We are participating at Project BuildOn, and I'm leading the theme on smart buildings and digital engineering at UCL. From our perspective, that theme and what a smart building is, it is something that uses digital technologies to serve the needs of the users. And it doesn't have to have a lot of sensors. It doesn't have to have a lot of infrastructure, digital infrastructure. What we're looking is what those needs are and how they can be best served with the amount of data available. And then I'll pass over to Kristian.
Hi everyone, I'm Kristian Mancinone. I'm from Icons, which is a organization dealing with communication of science and communication of projects related to research-based activities. And within that, we have a unit which is called social innovation, in which we try to connect people and technologies and people and in this case, smart buildings. So in the BuildOn project, we're working in the matching the needs of people living in these smart buildings and people of kind of trying to develop services and tools for bettering their quality of life in these buildings. And so for me, a smart building, I'm quite new to this kind of things because I came from the social sectors as kind of my past professional life. But as far as I understand, smart building is kind of digital integrated ecosystem that helps people to live better, thanks to intelligent technologies and the implementation of physical tools and services and solutions that can help them better in their life, in their environment. And I think I can go back to Matteo.
Yes. So the next two experts are Meritxell and Margherita, representing Ren+Homes. Please introduce yourselves.
Good morning,
Margherita.
everyone.
Good morning.
Sorry.
Okay, Margherita, you first.
It's up
As
to
you
you.
prefer.
It's okay.
Okay, so good morning. My name is Margherita Fabbri, and I'm a building engineer with experience in energy refurbishment of buildings. I've been working at RINA Consulting as a research and innovation project manager for the past 2 years, primarily managing European funded projects such as those under Horizon Euro program. I'm currently the technical coordinator of Ren+Homes project, a project that focuses on integrated renovation solutions for residential buildings, combining energy efficiency measures, renewable energy technologies, and smart systems to enable scalable and sustainable retrofitting across Europe, also engaging residents and end users in the decision-making process. And from my perspective, a smart building not only leverages digital and innovative solutions to optimize the energy use, but also adapts the needs of its occupants, creating an healthier and more comfortable and sustainable living environment.
Thank you, Margherita. Meritxell.
Oh. Now the microphone is working. Good morning, everybody. My name is Meritxell Barroso. I'm head of eco-innovation and sustainability at Evowall Technology. My background is in a chemical engineering with a master's degree in environmental management and an international MBA. To me, a smart building is one that applies digital tools to ensure both the highest construction quality and maximum comfort for its users or inhabitants. At the same time, it should enable a more sustainable building life cycle, helping to reduce the associated emissions. So it's two phases of the smart technologies.
Thank you, Meritxell. Thank you all. So before to go into deep diving of the three projects, so each of the project will be presented with a specific focus on smart buildings. We would like to interact with you, with the audience, with the Mentimeter session, with the poll. We are going to ask you 3 questions, and we would like maybe also to have your answers and discuss them. So the very first question that we are asking is which aspect of a smart building interests you? Okay, I see 70 people answered to the poll. So, okay, in any case, the first position is for energy efficiency and decarbonization. That is quite expected, at least from my side. Then the last part is occupant interaction with smart devices that in any case should be taken into account, at least is taken into account by our project. And of course, digitalization and data-driven solution are at the second place as for the interest of you. Okay, thank you. Then we can move to the next question. That is, what is in your opinion the biggest challenge in making buildings more energy efficient and smart? Okay, then we can already say that the cost and the technical knowledge are the most important aspect to take into account, and the biggest challenge in your opinion. Of course, the impact and the barrier of the initial cost is something important to take into account. I said at the beginning that there are millions of buildings across Europe that could be digitalized, and so this is very important, could represent a very important starting cost and barrier. But then the technical knowledge is quite important to try to address the point of digitalization. And today we are going to address this mainly, the technical knowledge, technical aspects, but of course taking into consideration costs of interventions. Okay, next and last question for you. Have you ever implemented smart technologies in a building project? And the answers could be yes, extensively. Yes, but only in pilot projects. No, but I'm planning to. No, I'm here to learn more. Well, this is quite unexpected for me because many of you are answering yes extensively. That is good, but still unexpected. The majority of you actually is answering yes, but only in pilot projects. That means that this is still good because you are in some way involved in this process of acquiring knowledge. Some of you are here to learn more. Okay, we reached 23 voters. Okay, so this is the situation. So we are still working and piloting these solutions, not only in our 3 projects, but I suppose in many others that you are participating on. Okay, so we can close this session with 1 minute in advance with respect to the schedule. And then we can move to the next session of this webinar that is related to deep dive into the 3 projects that we are presenting today. So there is the session of expert insights, best practices, and innovation. So for the next 45 minutes, the speakers are going to present their project with a specific focus on the topic of today. So I will leave the floor first to Anna and Pablo, Anna from Tecnalia and Pablo from TU Delft, presenting some insights from the SMARTeeSTORY project. Please, Anna and Pablo, the floor is yours.
Okay, I hope you can see my presentation. Pablo
Yes.
and I we are working on the project SMARTeSTORY, and we are going to present about the topic of implementing SRI in historic buildings. First, I present very briefly what is SRI and a web application that we've done to calculate it inside our project SMARTeSTORY. In line with nearly zero energy buildings introduced by the EPBD in 2010 as part of Europe's decarbonisation plan, the European Commission has identified digitalization strategies as the main factor to improve energy efficiency. The EPBD revision in 2018 introduced the concept of Smart Readiness Indicator, SRI, aiming to create new opportunities for energy savings through building automation and control systems. The SRI methodology for determining building smartness emphasizes various key functionalities, which comes from different measurable impacts, such as energy efficiency, comfort, convenience, obtained from different domains, like heating, ventilation, lighting. Each domain is composed of different services, which are characterized based on the functionality level. This result of this evaluation obtains a percentage, which corresponds to the SRI. Based on the SRI classification for European buildings from A to E, we've proposed a change in the grades to better reflect the current state of the lower SRI in the building stock, so it's easier to get higher grades, as the majority of the building stock is rated with an SRI less than 20%. Following is a generic diagram of the created web app. Its front end is related by a backend with European reference Excel, with which the baseline SRI calculation module has been designed. In addition, an optimization module has been integrated into this Excel, which allows the user to calculate the innovative contribution of the analysis of rehabilitation strategies to improve this SRI. From here, I will show a series of screenshots of the created web app. This first picture shows the homepage, where two paths can be taken. First, on the left, to calculate the baseline SRI, or second, on the right, to generate and calculate the improved solutions. The first tab is where the general information from the assessor is filled. In the next tab is for the general information of the building, like its typology, size, location. Then the user has to select if the domains that are part of the SRI methodology are present in the building or not, and if they are also mandatory or not. Next, for each domain, all the Smart Ready services are filled based on their main functionality level and share of the building that is applied. Finally, the overall SRI score is showed by the total SRI, its class, key functionalities, impacts, and domains. This facilitates the full interpretation of the SRI score. From here, the user can download a full report showing these results, as well as directly go to the next module, where are the generated proposed solutions. Here, the second module includes this novelty part, where is integrated the refurbishment strategies to improve the SRI score. Here, the web app loads automatically the scores and information from the evaluated building in the previous module, the baseline. The domains are then automatically sorted based from lower to higher scores, so it facilitates to the user to focus on which domains could improve the most. And instead of all 7 impacts that is presented in the SRI methodology, they are grouped as key functionalities: building, user, or grid. From here, the user selects its own preferences on what impacts and domains want to focus to generate the proposed solutions. In this tab, it shows all the possible solutions that increase the SRI based on the user preferences. From here, the user can create as many scenarios as they want with the same preferences. Then they must select those solutions to evaluate the new possible SRI. After their selection, the new SRI is calculated, presenting the SRI result for this improved scenario. In this tab, a full report can also be downloaded. In the final tab, the results obtained from all the different calculated scenarios is compared to the baseline. As default, the scenario with the highest score is highlighted. Again, the results can be downloaded for its practicity. Now, with our colleagues from RINA, we are integrating a financial assessment in the improvement strategy part. The objective is to improve the user decision-making. For this, we are updating the database with the cost for all services in a normalized function. But we observed that it's difficult to obtain all this normalized information, as well as we found that there are some duplicate elements. We expect in the next month or so to be able to integrate all this cost information to generate a cost-effective indicator that helps the user to better evaluate its proposed solution. In conclusion, this web app that applies the SRI methodology to assess building smartness identifies improvement strategies aligned with user preferences. This novel approach to maximize SRI scores enables the different involved agents to make better informed decisions for enhanced building intelligence. Our future work, besides the integration of cost effectiveness, is to improve the user interface of the web app and integrate these new functionalities. Thank you. Now I'll let the floor to my colleague Pablo.
Thank you, Ana. Hello, everyone again. So this part of the presentation will focus on understanding of occupant requirements with office buildings in particular. Okay. So I just wanted to start here as showing you two cases of high-tech solutions in a, let's say, smart building. On the left hand, we see how an occupant places a cardboard protecting themselves from glare, even though we have shadings, automated shadings. On the right hand, we see how the switch has been hacked to keep the shadings up, right? So we might think that automation will make our life easier, but sometimes it's not. And we have seen this in literature. There is this huge study from our colleagues from Berkeley that they asked 100,000 users of buildings about their satisfaction, and 40% of them were dissatisfied. One of the main reasons that they claim about dissatisfaction were the lack of control with building services, noise from HVAC systems, poor air quality management, and over-automation of those building services. So this is why we say that the user-centered approach is important, because we need to understand those requirements in order to inform better, let's say, smart strategies in buildings. For this reason, preliminary study that we did in the SMARTeeSTORY project, we developed a framework that is able to assess the satisfaction with human and building interaction in buildings. And we tested that with our demo site in Delft and our demo site, which is in Riga. We also have a demo site in Granada that we are testing our approach. And then in our case study, we did a questionnaire that we asked the occupants to rank the satisfaction levels with indoor environmental quality, the personal control, and the automation for different building services, and how different influencing factors might be affecting the satisfaction. And we have the access to control, the inherent preferences that occupants have, and the social norms, those dynamics that might happen in a shared office space, right? Just for you to see, we are able to see with this framework that the satisfaction with automation is highly linked with the access to control. And we have seen that in both demo sites. Another insight that we got from this study is that the satisfaction with personal control is highly linked with social norms. Let's say those dynamics like democratic approaches that sometimes happen in an office space in order to select the set point of the thermostat. So those dynamics are the ones that were triggering the satisfaction with personal control. Maybe, yeah, in this case, we might think about gamification strategies or other kind of smart approaches to kind of find an agreement, no, for interacting with building services. So in this part, we focus on the human-building interaction with interfaces. Okay, and the other aspect that we tackled in the project is how the automation, let's say that control logic that controls the building services is aligned with users. Because if we are optimizing for energy and comfort, and the occupant tend to override the system, we might lose those objectives, right? So we want this control logic to be aligned with occupants. This is just a diagram of how control logic works, but I saw that many of you are familiar with these technologies. So let's say that we have sensors, we have actuators, and we have building services, and then we have a controller which has some policy design that can be designed by an engineer, technician, or by means of AI by itself, in order to take actions in the space to improve energy efficiency and comfort, or the aspects that you may want. Okay. So just to show you briefly a study that we did, we might face in an office space many different occupant needs, different people with different requirements. So we try to test if some of those requirements were similar to each other. So we fitted personalized comfort models to see how people were having similar thermal demands. And we identify those kind of people that are always feeling warm, let's say the frost followers that we call them, the neutrals that are those kind of people that are always okay, and the heat handlers, the people that is always cold in the office, right? So what do we do, what can we do with this information in a control logic? So this is what we tested. We tested a control logic that is able to identify those three kind of people instead of all those thermal responses in an aggregated manner. And we ran a simulation to test how this would perform for thermal comfort and for energy consumption. In general, we see, of course, how tailoring the thermal conditions for the occupants will improve the thermal comfort. And in the case of winter, we also improve the energy consumption. For summer, the behavior was slightly different for energy consumption just because of the set points preferred for the occupants. And of course, when we tested this with an energy efficient scenario, we were reaching less values for energy consumption. But this is why it's important to develop multi-objective optimization frameworks that can identify those trade-offs. And I will just explain you briefly because I think my time is finishing. And what are we doing now and why this is important? So until now, we just focus in the latest part about the thermal conditions. But when we are in a building, an office building, in a building in general, many building services are multi-domain. And these aspects present as conflicting situations or trade-offs. For example, if I open a window for fresh air during winter in the Netherlands, I might get cold inside of the office, and this might affect the energy performance. This is just an example. Or when I'm controlling the settings for glare, I might lose the view outdoors or daylight. So if we need an optimization and a control logic that needs to control based on those trade-offs, we need to understand then better how the occupants might prefer those situations, because our hypothesis is also that occupants have different preferences for different environments in a multi-domain manner. So our research from now on, this Smart History project, is to understand this aspect of how those trade-offs or conflicting situations should be taken into account for better informing building controls. And that's it. We are also open to collaborate. I think that there are many experts in the session with us, and yeah, share insights about these approaches. Thank you.
Thank you. Thanks so much, Anna and Pablo. You stayed in the 15 minutes. That is great, but you also gave us a lot of nice information that could be also inspiring for next every one of us activities in the future. Thank you so much. So I leave the floor then to Dimitrios and Kristian to present some insights from the BuildOn project. Please, the floor is yours.
Thank you. Kristian, you go first.
Yeah, sorry, I'm trying to share my screen. I don't know if you can see it. I just shared it, but I don't know. I can't see it, so I don't know if it's.
Yeah, looks good.
Okay. So thank you so much. So we are in the frame of the BuildOn project. BuildOn project is a 42-month project with 20 partners, which works on energy efficiency in the buildings. And we are trying to kind of offer different tools and services, digital tools and services to 5 select buildings in different places in Europe and combine different technologies to kind of enable human-centered operation, improve efficiency, flexibility, and resilience of the buildings. The general aim of the project is to deliver these tools for our users, taking a user-centric approach, as we have seen in this project, and to develop an interoperability framework for the integration of multiple building assets, data exchange, and operation, and to implement AI-based system for monitoring, assessment, and prediction, and then to provide digital tools for the building performance simulations, and to define a better digital environment to implement the operation in these buildings. We have 5 pilots which are situated in different geographies in Europe, so western to east and north to south. So we will have different kind of climatic scenarios and different kinds of climate-related events occurring to the different buildings. So we will try to kind of understand the different situation in which the external environment will affect the buildings. We have commercial buildings. We have a kindergarten, and we have 2 residential buildings in the pilots. Why stakeholder engagement? Because we know that, as we have seen before, the engagement of different end users and stakeholders is really necessary at this moment to really better define the different usage scenarios in which a digital tool or a digital solution can be implemented in a building environment. And so we have defined different kind of, using this framework, we have defined the different research questions related to the different levels of engagement of stakeholders. And we have developed kind of social surveys and usage scenarios to better define how to engage people in the different pilots. This comprehensive framework was needed to understand user needs, to foster their engagement to participatory approaches, and design kind of different participatory activities that are being developed at the pilot level. We will provide them with the prototypes of tools and services to test and to enhance their interaction with smart assets. So basically, there have been 2 tasks dedicated to the development of stories and social service, and then the development of participatory approach, and then 3 tasks dedicated to the development of specific tools and services. Here we can see the diagram of functioning of the construction of the usage scenarios. So we have started identifying target groups, and then we created some personas, different personas for each pilot by talking with project partners and with pilot partners. And we define through these cards, we define some user stories, different user stories and usage scenarios, and that took us to define the different use cases for each kind of solution and the different climate scenarios in different buildings in different pilots. This has led us to the Deliverable 2.1, which is an analysis of the different user stories and the requirements that were needed. This has been done in the first six months of the project, and so this led us to really understand the specific needs that a user can have in facing the usage of these tools and solutions. And parallelly, we have done kind of definition of social. We have sent some social services even to other stakeholders to understand their perspectives on the usage of these digital solutions. And thanks to these integrated works, we have defined what we call social innovation roadmaps, which are simple tools. It's an Excel file in which we put all together the different activities that we selected to engage people together with pilot partners and with technical partners. And through this roadmap, we are able to monitor all the engagement activities throughout the project, and to understand which are specific needs and specific issues related to a single pilot, and then to give to technical and pilot partners guides and how to on the engagement strategies. And then we have developed this data collection template to monitor the engagement, only the engagement KPIs. So we are not talking about the impact of the solution on the indoor quality or what else, but only on the engagement of the activities. This has led us to the deliverable 2.2, which is kind of the strategy defined in the deliverable. And then we will have the report on the engagement activities installed during the next month, final months of the process. And we will integrate this with training and capacity building activities. So basically, dissemination and communication activities that have a capacity building and training pattern. So we will integrate these findings in the training. This is one of the pilot scheme that we used to really have a broad overview of what was happening at the pilot level, which were the level of engagement for different stakeholders related to the different tools and services that we are developing within the project, which are the external and internal stakeholders involved in the development of the tools, and so which are needed to be involved in the engagement activities, and tools and methods for engaging people and the timing. And this resulted in this broad roadmap, which has an indication of the different, in blue you see the activities that we have selected and the timing of the activities, so we can control and monitor constantly during the project implementation if there are some delays or if there are some other technical aspect that we need to manage in terms of implementing local activities. So we are now the partner developing and implementing the activity at local level, but we designed the strategies and we gave them some kind of even how-to guide that helped local pilot partners to make these engagement activities such as prototyping and testing, and we designed together with them some kind of tools and other things that can be implemented at local level to engage people. At this moment, we are kind of the month 24 of the project, so we are starting engagement activity after the development of the specific user the specific tools and services, and we will have some kind of results, I would say, in the next 12 months. And that's all by my side. Thank you for that attention.
Thank you. And so the second presentation from BuildOn is focusing slightly more on the technology stack and some of the work that has been happening over the first 2 years of the project. So what I would like to focus on, as Kristian mentioned before, is one of the main aims, which is that interoperability framework. To give some context, this is the main idea and our starting point in formulating our research hypothesis and research question. Within a smart building environment, we have different data providers, and there's a huge landscape in terms of data available. This data can come in different shapes and forms and formats, and we need to be able to ingest them and beneficially use them. So within an international project called IEA Annex 81, we have been looking at how we can go about doing that. And the main idea that we came is this high-level representation of the need for a platform. And that platform facilitates the data layer, which is the bottom layer, the integration layer, with an application layer that serves different applications. Now, the question is how we can specify that, how we can provide such applications. Just to give an idea of what these applications could be looking like, they can be automated fault detection diagnostics, it can be monitoring, but it can also be optimization and control. And BuildOn is focusing very much on that optimization and control aspect. So what we set out to do is set out to understand how we can do that. And this is not something that is not possible at present. It's actually done at present. The biggest challenge is that we need to do the integration and data access and everything manually and bespoke for each one of new buildings. So really the keyword here is scalable. So how can we go about doing it and scale it horizontally across a whole portfolio of buildings? And to be able to do that, we need to be able to provide generic methods to access data. We need to have a unified and a good representation of the building and its assets. So we need standardized metadata. We need to provide access to the data in a way that hides all that complexity around that heterogeneity, and then manage cross-cutting concerns around data reliability and security and privacy. And one of the main aspects of that is this standardized metadata, which we're working on, and we're using ontologies that relate to smart buildings, and I'll talk a little more about this. So this is focusing now on BuildOn. This is slightly going into more detail on what we have been developing. What we have been developing is going from left to right, different methods to deploy and capture data from sites and from the cloud, ways to access the data that can be deployed on the edge. And then as we go towards the right, move to the cloud, upload the data, abstract the data, normalize the data, and then serve the data to applications. And so we're looking at an end-to-end development and deployment and testing around different sites. So as I mentioned, this is a technology presentation. I don't have enough time to go into all the details, but there is several papers. But if we start looking at how this would look like, this would have a number of components, which are technology components, connectors to interface with different data sources, databases to store and provide data, and then equally importantly, APIs that are based on the knowledge graph and the ontologies that can serve and provide the applications. So we have been working within BuildOn and within Work Package 3 in developing that software infrastructure, which is defined and described in this paper in short. And then there's a deliverable from the project that gives 100 pages of the details of how that goes about, with the main characteristics that this is a modular, customizable, and scalable infrastructure. Now, in terms of the testing and the implementation. So some of our partners in the project have been looking at the edge devices. So going very close to the building and deploying gateways. And these gateways provide access to the data using multiple protocols. And then that information can be registered into our data integration platform. And this data that are coming from the building can be accessed, and also information like signals that can be communicated back to the building for control can be written. A very important bit, and something that we have been working quite a lot within this project, is that we get data in different shapes and formats, from structured building information models to information that might come from other platforms to unstructured data. So a big challenge is how we can take all that information and create that standardized knowledge graph-based representation. Kyriakos, one of the members of our team, has been developing this data integration and management platform that allows to do that in an automated or semi-automated way. Now, once we have the knowledge graph, we can connect to the data and store that information in databases like time series databases. And then we can also annotate this data with the metadata, so create a knowledge graph that comes and combines all the information that is available and generates that single source of ground truth with regards to how the building is represented. And that can help unify everything on top. Now, when it comes to applications, and this is something that we have been focusing in the more recent period, sometimes working with knowledge graph requires understanding of several technologies. One of them is Sparkle to query knowledge graphs. Another is how to query time series databases like InfluxDB. So we're looking at generating something that is quite simplified and is driven by the structure of the knowledge graph. And this is using a technology called GraphQL, and then applications can access data in a very transparent and easy to use for a software developer way, but without needing to understand everything that is happening on the back end. And that way they can access the building, any building, using a unified interface, and they can control the building or provide control commands using that same interface without needing to understand many of the details that are happening on the back end. So over the first 2 years of the project, we have onboarded now all 5 pilots. And in the next year and a half, what we're looking is at the applications and how we can deliver through that interface better control, better fault detection, or smartness upgrading. With that, I'll finish. I would like to give credits to my team, so I'm presenting their work, Kyriakos Katsigarakis and Flavia, and you can contact us if you want to know more about on that email, and then all the other partners that are working in Work Package 3 and have contributed to this presentation. Thank you.
Thank you. Thank you, Dimitrios. Thank you, Kristian, for this very, how to say, instructive presentations. You stayed also in time, so we're quite in line with the agenda. And so just a brief comment from my side from your 2 presentation. We are understanding that digitalized buildings is a very complex task that is not only involving technical solution and technologies, hardware and software, as Dimitrios was showing quite well, but also the user engagement, the user involvement, and also the social acceptance of this solution. And let me say that also data acquisition is a quite a crucial aspect of digitalization, because unfortunately, without data, we are not able to provide this type of services related to digitalization, such as digital building logbook, digital twins, digital performance of the buildings, and also BIM, for example. So it's quite important to take into consideration all these aspects of digitalizing a building. Then I would leave the floor to Margherita and Meritxell for deep dive into the Ren+Homes project. The floor is yours.
Thank you very much. So, renewable energy-based positive homes, also known as Ren+Homes, focuses on methodologies for positive buildings. So starting from some data, the building stock in Europe is responsible for around the 30% of total energy consumption and for around the 36% of CO2 emissions, with the most of their energy needs being met by fossil fuels. Additionally, construction and demolition waste accounts for a substantial portion of the total waste in Europe. And the European Green Deal fixed some very ambitious objectives to reduce of the 50% the greenhouse gas emissions and to reach the climate neutrality by the 2050. So to reach these very ambitious goals, we need to develop very innovative technologies for buildings, construction and renovation. In this sense, positive energy building is one step above the nearly zero emission building, because in the PB, the energy production is greater than the energy consumption, and the surplus can be shared through an intelligent network supporting other buildings. So Ren+Homes' main scope is to develop a universal methodology for positive energy homes and residential buildings to contribute to a sustainable transition by reducing the carbon emission while addressing resource scarcity and energy poverty. The 7 main project objectives are to develop a universal methodology considering embodied emissions, circularity of materials and resource scarcity, to select and upgrade affordable key technologies for building for both renovation and new construction, to engage the residents in the decision-making process to raise awareness and influence sustainable behaviors, to test the approach in 4 countries in both renovation and new construction, to develop the best financial strategies for positive energy and climate neutral buildings, and to influence the decision-making process at European level thanks to the liaison with 15 experts forming the International Advisory Board of the project. So the main expected outcome of our project is the universal methodology that starts from current methodologies that are not up to date and don't consider the resource scarcity and include the design and the operation of buildings. Then we also are developing as key technologies, so 9 hardware solutions, 7 software solutions, and 7 circular plus energy homes methodologies. The technologies are widely available and affordable to develop highly replicable technology packages to integrate hardware and software solutions. And the technology packages, as I was saying, integrate hardware and software solutions to streamline the progress and to create smart buildings. So the 23 solutions are under testing now in 4 demonstrators. Not all the solution in all the demonstrator, but every demonstrator focuses on dedicated solutions decided depending on the construction type and on the climate zone. Regarding the demonstrators, we have 2 construction in Innsbruck and La Garriga in Spain, and 2 renovation in Tallinn in Estonia and Cluj-Napoca in Romania. And Meritxell later will show better the Spanish demonstrator. To cover different type of buildings and also climate zone, as I was saying. And finally, this is the consortium of our project. We have 23 partners coming from 8 European countries with 4 different demonstrators. That's all from my side. If you want to learn more about the project, this is the link to our website, and I will leave now the floor to Meritxell.
Hi, good morning. Can you see my presentation?
Yes.
Okay, thank you very much. Just to start, I want to explain what is Evowall. Evowall technology is an industrialized construction company. We use a custom building system with concrete panels made to fit for each project. All our final constructions comply with Passive House standard. So we use smart tools in all of our process. I will show you now. And our buildings start from a concept or an idea and a traditional design created by architects or engineers. And in Ren+Homes project, we have built our first multifamily building. Although we constructed the entire building, only half of it means of these 7 apartments across 4 floors, is part of that project. In that project, in Ren+Homes project, the final result not only complies with the Passive House standards, but is also designed as a positive energy building with indoor comfort conditions and reduced CO2 emissions. To achieve Passive House Plus certification, a number of innovative solutions were integrated into the project, guided by the combined expertise of Evowall and the Consortium Passive House team. Detailed adjustments were made to optimize material selection, ventilation systems, heating equipment, and enclosed design. All of these aspects need a smart control after the construction. Also, special attention, as I said, was given to the selection of photovoltaic equipment to ensure compatibility with Ren+Homes requirements for a positive energy building. Since of Evowall's core values is the well-being of its inhabitants, Bioconstruction principles have also been taken into account. As Pablo said before, when the inhabitants are using the buildings, it's not easy that everybody understand how it works, the passive house, or how it works on the consoles. After that, or more than that, in the Evowall project, reducing emissions was a key goal. And we researched how to use recycled materials and create new insulation for our panels, together with ITEC, the Institut de Tecnologia de Construcció de Catalunya. We developed a tool to measure the environmental impact of the panels and in the construction and in all the construction process, also when the inhabitants are using the building. We collaborate with other partners during the design phase to improve the technical development of the project. With STIA, we studied different insulation materials. With wall sensing, we planned the use to monitor panels and building movement. With RINA, we worked on the design of safety sensors for workers, as well as environmental pollution sensors. When all those aspects and the final design are defined, the project is divided into the components that will make up all the panels, okay? We use different technologies to create a digital twin and ensure full traceability of every component. Then, when the design is finished, we start the manufacturing of the panels. They already include pipes for electricity and water, plus the metal structure. It's panel layers of plaster, concrete, and insulation. The panels are delivered to the site and in way to optimize the transport, and the build started for our system construction, for our construction system. So finally, the reality is coming. We design one building and then we make reality. So this is nowadays our construction in the demo site in La Garriga for Ren+Homes. And this is the actual building, how it is. As most of you say, smart tools is not used only in the construction system or all the traceability. Then the inhabitants have to use to understand how to use that, and they have to use that in a clever way. So it's important to enforce and to make possible that the inhabitants understand the smart systems. Any questions, please? I'm here for you.
Thank you. Thank you, Meritxell. Thank you, Margherita. So we are closing this session of expert insights, presenting the three projects. So now we are going to start the last session before the conclusions, that is panel discussion.
Matteo?
And question, yes.
Sorry to interrupt you. We got some questions in the chat for our
Yes.
speakers. I suggest maybe we let the speakers answer to this question. And we have a question for Dimitrios from Nicola. I will read the question. So for you, Dimitrios, how do you make sure that you don't create another silo with data software with your platform? And there's a second question also, how do you scale up and convince other partners outside the consortium to join the platform?
Okay, great. Yeah, thank you, Nicola. I think these are great questions. On the first question about the silo, right? What we find in many buildings, especially commercial and larger buildings, is that we have those systems that are quite separate. So, for example, lighting, occupancy, BMS, energy management, and so on. So one of the things that we're trying to do is kind of unify everything, and really the end user doesn't know or really care about where that information is coming from. It can be web services, it can be any of those aspects. I think what is happening today is we install things like Tridium boxes and Niagara boxes and do some sort of custom work to facilitate that interoperability. And really our solution, I think, is facilitating that bit to make it easier. Now, again, this is really or can be seen as a federated solution. So we provide a unified and hopefully easy to access interface. And hopefully this doesn't create another silo, but provides a more unified view of everything about a specific building. Now, on the question of how do you scale up and convince other partners, I think what we really try to do, and I think I conveyed in the last slide, is to make access to data as simple as possible. One of the experience on working with real buildings, and we have 5 in this project, is that the process of curating data and creating data and collecting data probably takes 80% of the time, and then there's very little time in the end to actually work with the data and provide something useful. So if we can manage to streamline and facilitate that process so that researchers like us don't need to spend that 80% of the time doing that tedious work, I think this is a very important win and kind of can help us create bigger and better applications. And this is exactly what we're trying to do with this Universal Building API. You don't need to understand anything about the building automation. You don't need to understand anything about how the data is structured, what is the structure and the infrastructure. You can really access the data you need and then write application using very simple API calls that do something interesting and useful for the users, whoever this might be. So I think that question around scalability is addressed through that universality and the use of the knowledge graphs on the back end. And then hopefully if people can see the value and the reduced amount of effort they need to develop and deploy a new application, they will adopt such solutions. And we think that can be a very useful way forward for the future of smart buildings.
Thank you, Dimitrios. And we have a second question from Valdis for Kristian. So about stakeholder engagement, Valdis asks, do you see impact from stakeholder engagement in terms of energy saving, and how big are they?
Yes, thank you. So at this moment, we cannot answer to this question because we are started now to take some kind of information from the building. So we couldn't say how big they are, the impacts of the engagement in terms of energy savings. We still have to start the training. We still have to start the real engagement of single users in each building, so we can talk about the impact. But what can we talk about is about the need to really involve them in not only see the solution, but understand the solution, because I'm not a smart user at all. And when I installed the smart thing in my house, I was kind of, okay, this is the instruction manual, but it was not comprehensible at all. So I think that what we need to do is not just to include their requirements and their needs in the frame, in the digital frame, but really to go to them and say, okay, what it works and what does not work for you.
Thank you, Kristian. And for now, we don't have any question in the chat or the Q&A. So Matteo, I will give you back the floor.
Yes, so if you have any other questions or curiosity to ask to our speakers, please don't be shy. So maybe I have some questions that raised to my mind when you were speaking. And for me, one big challenge in this process to making building smart and digitalized is the step from the design to reality. So in this 3 project, we are working a lot to design solution, but we are also trying to deploy and implementing the solution. So this question is basically address it to Meritxell and Pablo, because I know directly from SMARTeeSTORY project that Pablo is quite involved in deploying hardware and software to the pilot site of SMARTeeSTORY. And I understood from Meritxell that in Ren+Homes you have, and probably in other projects you have such experience. So what is the step between design to reality, and which is the main challenge for your perspective to do so? Please, Meritxell first, maybe.
Okay, it's not a easy question because it depends of every project, but in fact, probably there are two main aspects or two main points. The first of all is that the engineering or the engineers of the or the architects of the project understood at the first time that building have to be smart. So they have to understand that it doesn't matter what is the size of the building or what is the type of the building, but we need some information from them from the first day, okay? And then at the final of the process, when the inhabitants are using the building, this is a key point also. They have to understand, for example, in our buildings that they are passive houses, standard buildings, they have to understand you can't open the windows for ventilate your apartment for hours and hours, for example. You have a ventilated control, you have a heating control. So they have to understand and to change some culture. So probably the main steps are the first one and the last one.
Thank you.
Maybe I can go. Thank you, Matteo, for the question. Yeah, I listen very much of what Meritxell said. In our case, in the SMARTeeSTORY project, we are implementing. So we have existing office buildings, and we are installing smart meters, for example, for radiators, for the ventilation. We are installing also sensors for indoor environmental quality, and installing also automated actuators, no? Of existing components. We are not replacing anything. So in one of the challenges from design to, let's say, reality is that the selection of the materials and components that should be in place for an existing building is challenging, I think, from the technical provider point of view, because maybe they have like general solutions that might fit all of the buildings, but every building, of course, have its particularities, right? In our case, in the SMARTeeSTORY project, we deal with historical buildings. We have constraints from the policy point of view, but also from the way that those buildings has been designed. So sometimes finding a technology that is suitable for all buildings is hard. But in this case, we made it happen. But yeah, with some back and forth communication. And the other aspect that I think is challenging is because in this kind of pilot projects, there are many different stakeholders involved. And when the contractors come into place, maybe they are not, they don't understand well the technology that we are implementing, right? So there is maybe this lack of expertise or knowledge of the current trends that we are implementing in buildings. And this is a challenge that we face. We talk with them, we kind of read the manual of the solution, the diagrams, everything to have a common understanding, but they don't come to the meeting with solutions, let's say, they just have to, they come to implement the solutions, but we need to have meetings to have a common understanding of what we want in place regarding the smart solutions, right? So maybe those are the two aspects that in our case, have been more challenging from design to reality.
Thank you, Pablo. And now I have a question for Dimitrios. So I'm quite curious to know from your perspective what is the impact of data acquisition and data collection in smartening a building, and because I also I was also listening to you, and then when you say that not always there should be a huge implementation of devices. So I would like to understand how this can be coupled, with the data acquisition and data in general.
Yeah, I think, I mean, if I might say, following up on what Pablo was saying before, that I think what we can see and what we can verify is that there is a lot of value to be gained from data in leading to better operation or supporting users. So if we accept or acknowledge that, and we can debate whether that is true or not, but I think it most likely is, then what we need to ask is how we can deliver that value and how we can do that in a cost-effective and efficient way. And I think one of the mantras that has been happening in the past is we went from having too little data to having too much data. Many of the buildings that are built today, especially commercial, are being installed with a lot of sensors, a lot of equipment, a lot of digital infrastructure, and we end up being at the point of getting too much data. I think more importantly, or more usefully, the question could be how much of that data gives us something useful to go about working with that building. And to be able to answer that question, we need to start backwards and start with what are the problems that we're trying to face and address, and then work from that to what is the data infrastructure. And it might be the case that we're missing certain sensors. For example, the state of smart metering and sub-metering is abysmal in many buildings. And maybe we need to install a few sensors, or it might be that for the type of questions we're asking, we don't need all that fancy infrastructure, but very simple measurements that are available can be useful to understand how that building is operating. So that kind of paradigm, going back from specific questions to the amount of data that can provide some evidence in supporting and answering these questions, is probably a paradigm shift that we need to take into account. And I think what probably all the European projects that are funded under the Smart Buildings call are trying to do are trying to lower the barriers. And those barriers sometimes have to do with the users, and I think that was highlighted quite a lot. That barriers have somehow to do with the technology gap, and I think that was highlighted in the Mentimeter. And that barriers sometimes have to do with what is the data that we need and how do we share that data and how we minimize that risk. These are the type of questions that we should probably be focusing on, and then making it easy for whoever wants to use that data to use them without having to focus on this complex technology infrastructure or kind of accessing the data, because the barrier to entry for getting our building smarter at present seems to be quite high.
Oh, thank you, Dimitrios, for your explanation. And then the question of 1 million euros, probably to Anna, because then when it comes to costs and to different buildings to be addressed, the new construction or refurbishment building, then how, and this is a question to Anna, but to all of you, of course, how the SRI tool could help the designer to address the topic of digitalizing several buildings and from different construction ages. So the oldest one, the historical one, the newest. And how SRI could also take into account costs, as we are trying to do in Smart History, because then when it comes to costs, I think that the costs represent one of the main barriers now for people that would like to digitalize their buildings.
Yes, I think in the previous polls that we made, it was one of the raising questions, about the the cost of these measures. And I think when we are looking to increase the SRI, we are looking to very broad different options to increase the SRI. So maybe it is too much and we don't know which is the first approach. And I think including this cost-effective indicator, it could help the end user to make a better decision. And it's an informed decision, no? Because you are not only targeting an increase in the SRI, you are also looking forward to a budget, or you don't, I mean, there are different agents involved in this process of refurbishment. So if you can make a better informed decision, it's going to be the better for everyone, to the end user and also to the agents that are involved in this refurbishment.
Thank you, Anna. And I don't know if there are other questions from chat, but then
We have a very last question in the chat from Jose. In the case of smart renovation of historic buildings, are existing electrical installation reviewed or updated? To what extent is the building existing electrical infrastructure considered? A question maybe for our SMARTeeSTORY partners.
I don't know, Pablo, if you want to address the
maybe. Yes, maybe I can say something. Well, thank you for the question. I think it's very relevant. In our case, for example, for the Smart History project, when we, like, after the design of the implementation and the on-site visit, of course, we understood that the electrical demands of the devices and the electrical installation was checked on site. But there were no updates needed because we are just installing like low power devices like sensors and actuators. We are not replacing a boiler by a heat pump or this kind of renovation strategies. So it was not needed in our case, but yeah, it should be, of course, considered, and it's very important to check. But yeah, of course, it's considered. Like when we work with listed buildings, the requirements are very strong and very hard, and everything should be commissioned very tightly. We cannot leave things open. So yeah, it's review. But in our case, we didn't update anything. Neither in Matteo, maybe you can update him. I think neither in Riga or in Granada has happened. Like the electrical installation has been changed. I don't think so.
No, there is the in the SRI different domains. There is the lighting domains. There is the electrical vehicles, but of course, the electrical installation can be updated at some point, but yes, it's the electrical infrastructure, of course, is taken into consideration. Yes, it's an important topic to cover.
If I can say something, maybe I don't think the electrical installation is a barrier. I think it's something that is needed, therefore can be changed. It's not the same as, for example, windows. If we change a window, the outdoor facade might look different, and because the building is listed, maybe we cannot do that, right? Or maybe we cannot put like sensors on the facade because the facade is listed by the municipality. But when we talk about critical systems such as electrical infrastructure, I think all changes can be made. Because of course we need to supply power and also environmental quality, right? Or yeah, just services in general.
Okay, thank you, Pablo. So since 1 minute is left, my probably last questions in order also to close and to wrap up a bit this webinar. My last question is to Margherita. Since you are coordinating Ren+Homes, I would like to ask you what is dealing with the different how to say perspective that we have dealing with the digitalization of buildings, the different point of view, the different professionals that have to intervene in a complex project like this, because we understood from you, from the speakers, that the users are involved. The user satisfaction is quite important to achieve, to take into consideration. So we discussed about the user engagement. We are discussing about social acceptance of the intervention, active role of the end users in the control logics, for example. But also we have discussed a lot about hardware and software solution, data interoperability, and so how to then move to the design phase, to the implementation phase, how hard it is. So I would like to understand from the perspective of a manager of a project like this, how can every one of us can deal with all this expertise in order to increase the smartness of a building.
Well, in Ren+Homes, we are engaging the residents in the design process and also in behavioral studies to understand their behavior in the energy use before the positive energy buildings, and also after, to compare the results and also to learn something more about residents and end users. In the future, I think that digitalization in buildings is moving very fast from simple monitoring to predictive systems to artificial intelligence and integration with smart grids. But as buildings become more connected and data-driven, we must also focus on interoperability and data privacy to ensure that the technology actually improves people's comfort and well-being. So in my perspective, it is not easy to improve this process in the renovation, and mainly in renovation, because maybe new construction is a bit easier, but it is something that we must do in the future. And also these kind of projects like Ren+Homes, like BuildOn and SMARTeeSTORY, I think that they help a lot to understand better this implementation and to understand how to proceed also in private projects in the future for the renovation of buildings.
Thank you. Thank you, Margherita. So basically, I think that that's it. We can close the webinar. Delide, Kanisha, maybe just to say that from my side that we covered a lot of topics. Thanks to all of you so much for your intervention. Probably we have neglected a bit to discuss about costs of the intervention. Maybe this could be the topic for another webinar, because I think that the barrier of the cost still has a big impact for people like us, that they want to at least refurbish their homes in order to be smarter. But having said this, I think that we covered a lot of important topics in this ambit. So thank you so much, everybody, and I leave the floor to close to Kanisha and Adelaide. And you're muted, Adelaide.
Thank you. Thank you all for your participation and also for the insight from our expert. I think we all learned a lot, and we can only encourage you to follow the progress on our 3 projects, Ren+Homes, BuildOn, and SMARTeeSTORY. You can find us online and on social media. And as Matteo said, we are still a lot to discuss, so stay tuned and keep following us for following webinars. Thank you all very much.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Thank you.